Hello and welcome to Postgres FM, a weekly show about all things PostgreSQL. I am Michael, founder of PG Mustard. This is my co-host Nikolai, founder of Postgres AI. Hey Nikolai, what are we talking about today?
Hi Michael, it's your proposal actually, limit, right? But before that, let's mention a little bit what our companies are doing, because I think last time we did it 90 episodes ago, right?
Sure.
Yeah, so PG Mustard. By the way, I wanted to tell you yesterday, but forgot. During some session, people asked me about PG Mustard suddenly and
Cool.
asked, can I recommend?
What did you say?
I said yes, of course, and became shy. Like I should recommend it before they ask, right?
It's good that they are.
So yeah, we discussed some plan, and they wanted. Obviously, we discussed how important it is to use buffers. Our last week topic,
Yeah.
And if you haven't listened to it, please do. I mean, not you, but our listeners, right? Because buffers are super important, and there are many aspects. So, and they've actually found PG Mustard as a good thing to visualize and suggest. It's not my idea. It's yesterday's idea from my customer.
Nice.
Yeah. So, I personally think visualization is not the strongest PG Mustard feature. Strongest is a list of recommendations based on heuristics, which is quite a good thing. So, and I know you improve it all the time, already many years. So it's
Try to, yeah.
Yeah. So it's great. Yeah, and what about me? My company is now currently creating bot. Check out our latest, it's like few months old, but our blog post, my blog post, where I described how we build it. And currently we are rebuilding it fully. It will be interesting. The release will be soon. Yeah, it's quite interesting. We bring it to web from Slack. I think he will live in Slack still, but or she, but it will be in web. It's just easier to use it there. And we started using different models, including Gemini 1.5 with 1 million context window. So yeah, we change our RAG approach right now, and it's kind of interesting. It knows already more than 1 million documents about Postgres. It's huge. So yeah, that's probably enough about Postgres AI and PG Mustard, and let's talk about limit.
Nice, yeah. That's cool to hear. Yeah, maybe we'll hear more about that another time, about the differences between the models. Yes, so I suggested this topic, and it came out of a tweet a long time ago that I found myself recommending over and over again to people because it was a phenomenon I saw, and most people didn't understand or didn't intuitively understand, and including myself. So this was a tweet from Christoph Peters, and the headline was "Limit considered harmful" or something along those lines. And it was a really good kind of initial tweet for a thread. I was like, well, what? Limit's good. There's so many good things about Limit. It's really helpful for so many performance reasons. What's harmful about it? And he goes on to describe one specific case where it can cause plan flips and really, really slow queries in cases where you'd expect it to be helpful in performance. So that was the trigger for this topic. But it might be nice to discuss all the positives of using Limit, or at least when we should be using it, whether we should be using it, that kind of thing.
Yeah, well, first of all, I guess we will be fighting a little bit in this episode because we have different opinions. Let's start. I cannot be on the side of Christoph Peters in that tweet. I think there is huge potential because Limit, this is what every one of us is using all the time, right? Limit is everywhere. So if there are some cases when it's harmful, it's interesting. But my regular approach is if you don't limit, you're in danger. Limitless queries are harmful because you don't know if you test it. You know, my favorite topic, testing and experiments and how to test, and the idea that if you test on small databases, you miss. It's bad testing. It's anti-pattern unless you know what you're doing and do it before you test on full-size databases. So this is exactly when it's not even about performance. It's just if you test on small database, small tables, and some queries showing some results on a page, They don't have a limit. And we know all we start usually with it. If we prototype something, first we do it like, oh, forget about pagination. Let's show everything here. But then you test, it works well, like 1,000 rows on one page is not a problem, probably depending on how heavy they are in markup, right? But then project grows, and some users, for example, have 10,000 posts or I don't know, like comments, and you show all of them on one page, and you have problems. And this is postpone problem if you start new project, right? So limitless queries can be harmful quite easily, and this is a straightforward idea. If you limit, you know, at least you tell yourself what to expect. Okay, I expect 15 rows, for example. Okay, we know it's good. Like we know how many buffers we should expect in the very efficient query. 15 times the width of row plus some internal buffer operations, continuing the topic we had last week, right? Yeah. And that's it. Yeah. If you don't have limit, you don't know what to expect. Maybe it's a billion rows.
Yeah, so I agree, and I think pagination is quite a good place to start, because when people think, like, if you look it up, limit in the docs, for example, you're also going to learn about offset, and it's a really common kind of set of keywords. Well, yeah, so I'm a big fan of, I'm going to say friend of the podcast, Marcus Winand, previous guest.
Yeah.
I've always wanted to say friend of the podcast, so maybe finally got to say
it. It was a great episode.
Thank you. And yeah, it was, so he has a page on his website called No Offset, and I just
use the No Offset hashtag on Twitter. I use it all the time, because when we discuss, when somebody mentions offset, and this is not an expert who is doing offset on purpose, knowing why, basically, like for example, index only scans before you fetch the, you deal with regular index scan. There you probably won't offset sometimes, but very rare actually. So I always use this hashtag no offset. It's good.
I'm sure most people listening know exactly what these things do, but just for clarity, when we use limit, we might add like limit 10 to the end of our query, limit 20, limit some number, and that will, as the name suggests, limit the result set to that many, that many rows.
I use sometimes. Do you use limit 0?
No, but I've seen quite a lot of offset 0.
I use limit 0 when in two cases. When I, for example, create table, I select specific columns limit 0. For example, sometimes just to bootstrap some table. I don't want to repeat all data types. Sometimes it's like you're dealing with CVS or something. And also when I do tests, for example, presence of column, you can just select that column from table limit 0, not caring about anything. And nice. Yeah, kind of assert. So
yeah, I've seen that really cool use case. I've seen offset 0 used a few times. So offset is so limits the first n results. I've never thought of using 0 for that. It's cool. Offset will jump you forward that many before you start limiting. So you could offset. You take the first 10, throw those away, and then limit will take you the next 10. So if you do offset limit 10, offset 10, you get the second set of 10.
Yeah, and offset 0, it's either some RAM generated, right? Because it was offset n where n is 0, or it's also there was some performance trick, some hack, right?
Yes,
I already forgot.
It's quite. Yeah, I think it's it is or was an optimization fence, so it can trick the planner into not doing certain optimizations. Which I guess we'll get onto a little bit, but there is an interesting line in the docs.
That trick, or it was mitigated?
Well, something in the docs made me think it might. I think they still work, because I remember reading in a hacker's thread, or it was in a thread somewhere in the mailing list.
Yeah, so many times maybe used, but it's like was so long ago. That's why I'm wondering if it's still actual.
So I read a line in the docs in preparation that the offset 0 is the same as omitting the offset clause, but I don't think that's quite true because of the planner implications. But in terms of the result set, that's true. In the result
semantically it's true, but physical execution might be affected with presence of offset 0.
Yeah. So the reason I brought this up entirely was because we were talking about pagination, right? We can both common ways of paginating use limit. One is the kind of crude way of doing it, and a lot of ORMs, a lot of tools implemented it this way, at least initially, was to the first set of, let's say, 20 rows that you want, just add limit 20. The next set, they just did offset 20, limit 20. And then the next one, offset 40, limit 20. And the problem with that is performance degrades linearly over, like, as you go. And if you want to do if you want to get to page 20 or page 100, that can be quite it's very inefficient query. And Marcus wrote a great post about why we should instead be doing key set pagination for predictable performance and efficient queries.
Explanation is simple. It's just because internally it fetches everything until that and discards. And It's like a lot of inefficiency. It grows with the depth of your paginating, right? So
So what we were talking about in terms of good is where ID is above, like, or where some parameter is greater than some, like the last result you fetched, and then still limiting by 20 or 21, depending on exactly how you want to do, like something like that.
So limit 0 can be a problem, or limit 10 can be a problem, right? Let's talk about this problem, maybe, right? Because I hope I already explained why limit is good in terms of performance, because you limit, you understand yourself, what to expect, and you know what is efficient and what's not if you look at buffer operation numbers.
I think there are a couple of cases, like even simpler cases, like it is, chances are you don't want, or like if your query could return 100,000 rows, do you really want all of them? Or do you might only be interested in the top 10, or maybe your user might only care about the most recent 10, and returning all 100,000, even if the query is quite fast on the server side, sending all that data over the wire is inefficient. So I think it's kind of like almost a more fundamental reason that limit is good for returning a subset of rows, exactly what it's designed for.
It's close to our topic about delete and batching. By the way, someone asked on YouTube comments, how about updates? And I explained it's very similar, but with additional things. So if you don't batch and send the whole result set in one shot, what if not only just it's like a lot of memory and so on, but resiliency, reliability, what if it fails like in the end of processing, you lose everything, right? And retry will be huge again. So it's better to go in smaller steps and with retry logic. And limit, of course, is the key tool to split to batches. So pagination, batching, we need it, right? And also, in general, common sense, if I limit again, like I know how much I want, this is my request, I want 15, for example, or 2500. And if you scan many more parts of database, then these 15 records or 25 records plus additional internal like index pages and so on, then I'm not considering this as efficient work, right? So it sets a simple expectation and metric for efficient versus not efficient comparison of queries, right?
Yeah, I think that makes tons of sense. Like in application code, for example, you are you're kind of communicating with future developers what the expectation is here.
Yeah.
I think this is where we're going to start to differ in opinion, though, because I think this is exactly let's say on an ad hoc query, I've sat next to people working on production systems that were quite scared and saw them and didn't think this was a problem, actually was learning from them at the time, they were only expecting a single row back, and they added a limit 1 at the end of the query.
For example, in primary key lookup, right?
Yeah, I think it might have even been like I can't remember exactly what they were doing, but they definitely added
primary key or unique key. It cannot hurt because it's like if you don't trust Postgres unique keys, you add limit 1 just like as a cert, basically. Like you think, okay, like I must check it should fail or something, like if it returns more. Something like this.
Yeah, I actually can't remember exactly why. The thing I remembered was, that's quite a clever way of
actually,
not having a runaway.
1 second, I remember I did different thing. I did limit 2 on purpose So if something goes wrong and I have two rows, and then I don't remember where, but somewhere I should have error or exception, catch it and process. So limit two was where like it should be unique. So I expect one row, but I add limit two on purpose to check later that it's not two.
Yeah, I like it.
But yeah, so anyway, like in my opinion, the limit is always, like, I would add it like as a must for everything.
Mm-hmm. I think the fear was in this case a runaway sequential scan across a huge table that might start to eat resources and cause, like, I think this was a very, very on fire server.
I'm thinking now, and I think like maybe I would just even consider this as a rule, mandatory, like limit everywhere. And the only thing we cannot limit is, for example, select count star from something. This basically deals with all rows, returns just one number, and we cannot limit there, unfortunately. They're okay.
Well, you can add limit. You're just still going to get the count.
Yeah. Limit will be useless in this case. Yeah, definitely.
The interesting thing, though, and I was looking back at just for fun, could I find a version of the Postgres docs that didn't have limit in it? I'm sure it's like as old as time, but it was in an old version of the docs. I got back to 7.1 because that's the oldest one online, and there was a really, like, I got way more than I deserved looking back at that, and it said, as of Postgres 7.0, the query optimizer takes limit into account when generating a query plan, which I thought might be a nice segue. So before 7.0, there wouldn't have been any danger in adding limit to your query.
I disagree. I object. Mind your language. This language is wrong. Like, any danger adding limit? There is no danger in adding limit. Let's already jump to the core of the topic. There is no danger in adding limit. There is danger in having bad statistics or expecting some wrong, like forming expectations based on indexes which cannot support your order by with filtering and limit.
Yes.
So by the way, when you will describe this case, focus on order by as well, because without order by, this case is impossible. It's not about limit; it's about order by plus limit, which forms expectations. Like, I mean, gives planner the ability to use some index, right?
Yeah. Order so let's talk about for anybody thinking we've jumped, I shared some examples with Nikolai before the call so that he knew what we were talking about.
I saw this example before you, like, long ago.
Oh, sure.
I saw it live.
Well, that's good. So let's back up and try and explain the problem or the edge case or whatever you want to call it. So exactly the same query, if you run it with and without limit some number, can be dramatically slower with limit the number added than it is without the limit at all, which I found really counterintuitive. And yes, it relies on some specific cases, but those specific things are not as rare in the real world.
It's not rare, I agree.
Yeah. So that person sitting in front of that console, hoping that limit some number is going to make it safer and guarantee faster execution.
Same logic is expected. Yes, I agree.
Can actually shoot themselves in the foot and make things loads worse for themselves. And I actually think there might be other advice you could follow. Like, I would much rather they added additional where clauses or like other things than an additional limit. So that's potentially controversial. I'd love your take on it, but let's try and explain how this can happen. So the simplest case is to limit by a relatively rare condition and then order by something else that you have indexed. So, for example, created at. So if we think about let's say a software as a service business, and maybe you have a customer that cancelled a few years ago, and you want to look at like their most recent event or something like that. And so you're looking at by a company A, order by created at descending limit 1, something like that.
Or limit 10.
Or limit 10, yeah, exactly.
It can happen. The problem can happen with not only with 1. It can be some small number.
Yeah, it could be a big number.
Or relatively small. The key is that it's small enough to have flip.
Yeah. Well, Christoph made a good point that I haven't tested yet, that he thinks it's worse around the point of the actual number of rows. Like there's some cases where, let's say that company had 1,000 events, the limit 1,000 would be actually one of the would be problematic. So the problem comes from not knowing. Like Postgres assumes things are randomly distributed unless it knows better, unless it has statistics to suggest otherwise. And if it thinks that the table that contains these events is going to have events from any company in any order, it because it knows it only has to fetch 1 or 10 events, it now has this optimization where it might be quicker for it to scan backwards through.
You missed a very important thing. Let me add things. So we talk about, for example, case you took some SaaS system, some users, and users have some activities, let's say like comments or I don't know, orders, anything. Yep. So we have orders table, for example. This is what you showed, if I'm not mistaken. I remember
something like something.
So orders, and we have user ID, we have created ad, we have ID of order, enough, right? And the key here is we want to select all orders for this specific user in chronological order, like order by created at desk, so like in reverse order, the newest first, the latest first, right? And then the key here is not to forget. Our developers, or we are developers, we don't know about multi-column indexes. So we created index on created at, we created index on user ID and on ID. Okay, let's assume, let's simplify assumption. We like to index all columns. If it's worse, and when we do it, we use only single column indexes always, right? This is quite classic example. I can imagine it happens in life of every engineer during 5 years, for example, of development. Definitely, at least once it should happen, I would say. And 99% of developers, it happened with me many times, and with my products, my databases, and also with others when I observe them. Actually, recently we had it. Similar case, maybe a few months ago, I remember. So the key is Postgres needs to choose. Okay, I have filter user ID, and I have order by created at desk limit 1 or limit 10, and I have 2 indexes. So I have 2 opportunities here, like to save in terms of IO operations. And, of course, like Postgres should avoid sequential scan here. It can be one user of many, of millions, right? So it can be huge table. So we don't want to scan whole table. So we need to choose only one index or 2 of them, and maybe combine with bitmap scan and so on. But 2 opportunities here: filtering by user ID and also create order by created at desk limit 1 or 10. And the key here is order by. Without order by limit, it will be fast always, because order by is the key to consider index on created at.
We need both the equality check and the order by to make it a choice for the planner. Either has to filter on the equality condition with one of the indexes, take the data and sort it and return the order, or it has to choose the index that's ordered and take the first row it reaches that matches the equality condition.
It can be not necessarily equality. It can be between 1 and 10.
It could be any, So sorry, it doesn't also have to be an order by, right? Like it could be it has to be 2 separate conditions, and those have to
They fight between each other, right?
Yes.
And how do they fight? They fight based on costs, based on statistics, and what planner expects in terms of cost. And the key also, like important point here, is that planner has 2 costs: startup cost, which can be very small. It means first row it can be returned very fast, and also the full cost. Full cost is the most important when planner, like the full cost is what planner uses to make the final decision, choosing between variety of plans, right? Full cost.
Yeah.
So our case index on user ID, if we use just it means planner thinks, okay, I will choose all rows for this user, but then I need to order by them in memory, right? It means startup cost cannot be close to 0, because ordering and so on, it will take some time. And only once done, we can return all the rows. I assume, like in this case, startup cost and the final full cost, they are very close to each other, but far from zero, probably, right? But the other option, order by created at desk limit 1 or 10. This option means that we immediately use created at index. We start fetching rows from based on there, but we need to filter out irrelevant rows
Yes.
owned by different other users, right? We only need our user ID. It means we start returning rows quite quick, but only if we find our user ID quite quick. There is uncertainty here, but for Planner it's quite certain because it has some expectations about distribution. You mentioned it, right? So probably Planner can think, okay, I will be lucky because this user maybe it's not rare user. Maybe it's still super active, by the way, because we start from the very fresh rows. The latest row will be considered the first, and if our user ID is there, it means we are already found one row, so like in the first step already, right? And I go. But if this user is super inactive last year, for example, in reality, we need to scan whole year to reach the first row of that user to return. And here is exactly where the planner can be very wrong. I mean, it simply doesn't know.
By default.
It doesn't know. There is no correlation in statistics between user IDs and created at, and also planner doesn't know who is recently active, who is not. Planner doesn't know, so it can be very wrong right here.
So there are multiple. So I completely agree that. You brought up multi-column indexes. In the case that I shared with you and the case we just discussed, a multi-column index on the user ID or whatever it was, and then created at ordered, would make this query efficient and predictable all the time. And so if this was an application...
For me, it's not that of limit, lack of index. Okay.
Yes. But if this was an application query and this was showing up in pgstat statements as a problem and we needed to optimize it and it was one of our biggest concerns, we didn't mind about the overhead of adding another index. Great, we can add this index, remove the one on user ID or whatever we had, and it would be fast all the time. But what I was talking about a case where we're sitting in front of a console on production, trying to stop ourselves from running a large query or a slow query and adding that limit, even though we didn't think it would make a difference, even though we think we're only going to get 1 or 2 rows returned. If we add it, we're taking a risk that it could actually make things worse because we don't, if we don't check. And this is actually maybe what I would recommend. I don't know about you, but if you add explain before the query and just check what index it's going to use, does it make sense? If we saw it was going to do a backward scan on created at, maybe that would be a sign that it's a bad idea. The tricky part is this is an issue because of a cost underestimation. So it's always going to look like a cheap query in cost. The reason it's being chosen, if it's a bad plan, if it was a slow plan, is because the planner's thinking it will be cheap. It's because it thinks it can abort early. So costs won't give you a clue here. You'd have to be attuned to the fact of which indexes it's scanning, and is that enough? Is that a good idea for this query?
Mm-hmm.
So I'm talking about production cases, where you're doing ad hoc queries, not so much application queries where you should optimize.
Yeah, for example, we need to return our table and allow users to order by all columns in both directions. It's nightmare to support in terms of performance.
Yeah,
and if you have many of such tables, or maybe you allow users to create tables, any tables, and you want to hide this performance optimization from them. Some builder of website builder or mobile app builder, and you can say, okay, your users are developers of website or mobile app, and you say, I allow you to create tables. I will take care of performance. In tables, you're allowed to create columns. I will take care of performance, and you can put some element on your UI for your users, millions of users, and you can allow them to order by any column. In any direction. It's a super nightmare, absolutely nightmare to support, because obviously you want to create index on every column, and also you think, okay, I'm smart, I know about key set pagination. You add pagination, you then allow this is exactly where you can encounter it, right? Because this limit.
Yeah.
So I wanted to emphasize again, like I described, one index has very low startup cost. It's created at index. And why it's low? Because Postgres doesn't know for arbitrary user. We probably want this query work not for one user, but for arbitrary user, right? Right. So in this case, you probably like if Postgres doesn't know for this particular user how fresh activity is or orders are, right? So maybe, but it assumes something. It can be slightly more, slightly less, depends, but it assumes something. For second row, it's 2 times more. 10 rows to 10 times more, and this is our like. But once we found, we don't need to do anything if we traverse created at index and just filter out irrelevant other users, right? We just need to find our users. Once we found our n 1 or 10 rows, we are happy. This is our final cost. And then if we don't use limit, our final cost is our expectation for this user. This statistics probably is present, probably, unless we don't have at all statistics at all. Postgres expects for this user ID, I expect this number of rows, and this forms our total cost. And probably if it expects a lot of rows, total cost will be high and it won't start using this approach. In this case, it switches to the more reliable approach. I will fetch all the rows and do in-memory sort. So the key here, like if we limit, this is probably why Christoph mentioned that this is the boundary is this limit. It's not the actual number of rows, but it's statistics, Postgres expectation for number of rows for this user ID. Exactly.
Yeah.
So when our limit goes down, like below it, right, below this number, our traversal with filtering out irrelevant users becomes more attractive because total cost starts looking good there. But it's a trick, right? Because the problem here, like it's a trick, and of course it's super interesting phenomenon. I would say this is a phenomenon. Yeah. It's not a harmful situation because there are many cases when limit doesn't help. For example, we don't have indexes at all. We say, well, no,
that can really help.
It can help. It can help. Yeah. Because filtering out, it can help. But it's easy to imagine when limit is useless in this.
Actually, that's another time I use limit. So the docs are quite.
Adding limit in sequential scan, in general case, improves performance because you will stop earlier. But on edge case, when our record is the latest in scanning, it doesn't help. Here we deal with similar situation. In general, it's good, but we have some edge case which not only doesn't help, but it decreases performance. But it's an edge case and it's phenomenon. It's not a harmful limit, especially because you cannot do this without order by. And especially because the problem here is not limit, but lack of proper index to column index.
And again, we're talking about I'm talking about a one-off query rather than like an ongoing optimization challenge. I'm talking about it's just an interesting phenomenon that, and I don't think most people expect this, that by adding limit you can make the query slower. And that's true. Like it can be a lot slower. So I just don't want people to use that as their safety mechanism.
When you understand what's happening inside, adding limit. It's clear why it's wrong. It's clear. You force the planner choose the wrong index here, right? Yeah. That's it. But of course, for people who don't dive inside the execution and planning process, they of course are very surprised and think a limit is bad. Yeah. But remove order by, and you won't see this effect, right? So.
But the docs, and this is what I wanted to say. The docs quite often, when you're reading about limit, will say. It's really sensible to use order by with limit because otherwise you're getting things in an undetermined.
Again, 1 second. Like if we talk about arbitrary or user ID, what if this user ID is super active and created 1,000 rows, right? Orders right today. In this case, it's planner was right. So that's why I say this is not even edge case; it's a corner case. You have several
funny.
things. You're in the corner here and observing very strange effect phenomenon. Of course, it makes sense, but create proper indexes. That's it. But at least let's correct this harmful title. Let's say limit one with order by considered harmful. Order by limit.
It's not just order by, though. It could be another condition that you add.
Lack of multi-column indexes, order by limit considered harmful. This is the full truth. This is the truth actually here, not just limit. Poor limit.
I was hoping you'd understand my point of view on this. It feels like you haven't. I do think that in a lot of real world cases, people don't have perfect stats, or they have data that's correlated it strongly in certain ways. For example, like user ID and account ID being extremely tightly coupled, or the age-old city and country codes. And Postgres assumes that all of these stats are uncorrelated by default. And if you don't, you can create statistics for these things. But in a lot of cases, we have a lot of skewed distributions in databases that we haven't created extra statistics for. And most of the time, the plan is great and can work things out like nicely. But by having this limit optimization, it can flip plans that we're not expecting to flip. And the reason I found it so powerful is we're using it exactly in the cases where we're most scared of doing a big scan on production. If that's what you're really scared of doing, and this is something that can
Michael,
actually cause
why I cannot agree with all this concept that is harmful? Because imagine we don't have an index on user ID at all. In this case, created ad shows bad performance because user is not became inactive last year. We need to scan whole year, but at least we have some approach to scan, right? Created ad adds some order of scanning. Without that, we only have sequential scan, right? That's it. So the problem is we don't have proper index. Now, okay, it turns out we have index on user ID. It happened to be helping, but what if some user has 50% of whole row, like records, like millions of orders?
Bear with me. This is why I'm suggesting, instead of running the query on production and adding a limit 1 or something to make it feel safe, instead of adding limit 1, put just one word, explain, in front of the query, not explain analyze buffers, just explain your query without the limit and see what the query plan is before you run it. If you're scared of what it's going to do on production, do that instead of adding the limit, and you'll see what indexes it's using, whether you're missing one or whether
not add limit, because I don't want my page to blow up because of many rows returned.
Well, add limit 1 and put explain in front just to check what it's going to do. Because that's what's really going to check. Like, that's what's going to...
You will check the planner behavior, right?
Yeah, you're checking what you're actually scared of instead of assuming you're going to be safe. It's like, I understand your point that it's almost never going to be a problem, but imagine if a safety on a gun, for example, like almost always kept you safe. It's like a safety feature that's almost always good, but like sometimes it's going to actually shoot you when you press that safety catch. Not when you pull the trigger, but when you press the catch.
Again, in my world, I add limit 1 to limit things. If it doesn't work, it means I don't have index. If there is some index which would help me when I don't have limit, I don't care, because I do need limit 1 anyway.
And maybe you'll hit some like statement timeout, or you'll cancel your query quickly, or there'll be some other safety mechanism in place that will stop you from hurting yourself.
But still, if with my limit it behaves not good, I'm looking which index will help. And I'm not considering index on user ID as helpful here, because I don't want to deal with a lot of records in memory, because I need only 15 records. So that's why I jump straight to multi-column indexes here. And as we discussed...
And I agree.
Yeah.
I agree that to optimize this query, but we're not talking about optimizing the query. We're talking about, should you use limit as a safety feature when you don't need it?
Why might I not?
Let's say you know there's only going to be one row. Should you add limit 1?
How do you know
as
it's only one row? Unique index? If you have unique index, this problem won't happen.
Let's say a company could set up multiple things but they generally set up one. Like, how many websites are you going to have for each organization? You don't have a unique index on it. People can add a second,
Okay.
but almost everybody
or emails
adds
for
one.
user, for example, right?
Yeah, email addresses. Yeah, it's probably going to be less than 10. Like, you don't have any, but maybe you're not certain it's going to be like one, but you're pretty sure it's going to be one.
But am I having up-to-date stats or no? Because stats will say they will form expectation to Postgres, and if it's a low number of rows, it will prefer.
I think I'm struggling because it's a simplified example, but if we've got lots of joins going on, there could be all sorts of other like complexities.
Joins are tricky, by the way. The same problem is becoming much more tricky, but I don't think limit is problem. I think the problem is lack of proper indexes, and sometimes you cannot create them. Imagine user ID is present in one table, but created that is present in different table.
So you're saying you've never sat in front of a database where you don't know all of the indexes in the system, you don't know the state of stats, and wanted to run a query and not been scared that it might take a long time?
Well, when I do this, I add limit. I understand that if I lack proper index, that will help. I might be dealing with sequential scan or wrong index being scanned almost fully, right? I understand that.
Yeah.
If you don't understand that, that's strange, right?
Well, but then, so that's kind of my like takeaway. Instead of adding limit 1 and hoping that I'm okay,
let me give you an example. I saw before what we discuss today. So we have full text search, for example, and we have rare words and we have very frequent words present in like majority of records in TS vector.
Nice example.
Right, and then we have created at or ID, and we want order by, and we want to find all matching documents and return only 15 latest, for example. In this case, Postgres must choose between ordering by B3 and then applying filter to add signs, right? TS vector at TS query, or it might decide, okay, I need to extract all documents and then order by in memory and then limit. Same problem, completely same problem. And I saw terrible cases when I thought, wow, like, why do you do this? Why do you think this word is super frequent? So you, instead of using GIN, you decide to use B3 to order by limit 15, for example. And then you end up scanning almost everything, finding my 1 or 2 records only in the end of scanning. It's absolutely the same situation. But the problem to me is not limit there at all. I put limit, I see the problem, I understand. Limit didn't help, I understand why, because we need to combine both things in one single index and have only one single index scan. Unfortunately, this is impossible there, right, in this particular case, because for that you need to use a RAM index, and it can be not available in RDS, for example, it's not present. And it's
or like work out some middle ground, take way more rows than you want, and then sort them, that kind of thing.
Right. So I mean, we sit on the edge here. We might be lucky, but we are not. And what else? Like, what can I say? It's not a problem of limit. It's a problem of lack of index.
So, I think let's try and wrap up. And I think I agree with you that to solve the performance issue, you don't get rid of the limit. You add a good index, or you get your stats, like you work out your stats correlation, maybe create some statistics there. Maybe you just need to run analyze on that table, or maybe globally. Like there's lots of ways of solving it so that query doesn't run slowly again in future. I just wanted to publicize and share that. And by the way, I wanted to shout out Frank Pasho, who got in touch recently when I shared this Twitter thread again, to say to I think we agreed that it's an optimization problem. And like he would completely be agreeing with you right now. I just found it really interesting and quite counterintuitive. Like, probably sounds like more than you did, that it could like just by adding it could make a query slower,
Right.
even though that's the sign of other
Right.
issues. So I wanted
It's
to
an
publicize
interesting
that a little bit.
phenomenon for sure. And
Yes.
adding a limit is not a performance optimization tool. Performance optimization tool is order by, limit, and proper index, like together. And
Yes.
adding limit, I'm not. I should not expect quick execution. I just form expectations for myself, and I can then say, okay, this is not what I want, and find better index, which is sometimes not possible if, for example, Gin versus B-tree,
Sure.
and so on. But by the way, to be fair, with Gin statistics already, Postgres is quite often right. So it knows when to use B-tree and quickly find proper
Nice.
results, and it knows when it's better to find everything and order by in memory. So it's not that bad, but also not ideal, not just single index scan.
Yeah. Cool.
Okay.
Thanks so much, Nikolai. Take care.
Thank you. Bye-bye.